and you can watch this back as many times as you like. But no, you don't have to sort of participate in any way unless you want to. I hope you do. The way these events have worked in the past, in the real three-dimensional world, is we usually have a room full of about 100 people, a big central point where we have all the coffee and all the biscuits where people mill around, and we just hit you with a set of resources or questions, and then collaboratively together we try and make sense of them. Okay, so at the end of the day, in fact, I've got a little thing here. I need to share that with you. Where have you gone? Here it is. Let me bring this over here. So what I've got here is our event resources for today. Now what I'm going to do, I'm going to copy that link there, and I'm just going to pop that in the chat. So I'm just going to pop that there for everyone. So if everybody clicks on that right now, that should bring up a browser window that looks very, very similar to what you can see there. Now, this platform is called Google Colab. If you have used Python before and you've used Jupyter Notebooks before, it's essentially a web-based version of that developed by Google. Before I take you on the tour and show you what you can do, if you get that up and running, you will need a Google account, probably, I think so, to access this, or at the very least to make a copy and start editing yourself. So the format this is in at the moment, this is everything we're going to, well, not everything, we're going to try a few things today. I'll go through this in a second. But what this really is a great environment for the likes of me and Sam here, just to talk through some stuff and also get you to type along. So we're gonna ask you at strategic points today to actually join us as we sort of do a bit of Python. The best way to do that from this point, I don't think you can't edit this file as it is, but you can make a copy of it. So I urge you right now to click on File, and then you should be able to click Save Copy in Drive, like that. Okay. So if you do that, I think it asks you whether you want to open it up in a new tab. Takes a couple of seconds. There you go. Notebook copy complete. Open in a new tab. Okay, so that should then be associated with your Google account, and you can actually start. If I go to the top here and I just click the plus code button, you can type something like print hello world, and there's a couple of ways you can compile that. You can press the play button here, and that'll just print out hello world. I hope if you're just running this up for the first time, it might take a couple of seconds to initialize. I can see the initial, there you go. And there's my output, hello world. That's probably going to be your first line of code today. I'm going to go back to the version I was working on. I'm going to work through that. So at the end of today, whatever happens, you'll always be able to come back to this resource and use it. And what we do is between our introductory sessions, we don't like to do the same thing twice. So we pick and we tweak it and we add a few things. So you can see I've got the table of contents. Let me zoom in a bit here, guys. I've got the table of contents for today. We'll have a quick natter about what our aims and objectives are, why we're here. I'm going to showcase our existing resources that people like Sam Ball, Sam Cassidy, I don't think he's here today, have worked incredibly hard to put those together for you as a resource that is always available to you. I'll show you how to get hold of those. I'll hit you with the basics, the absolute beginner basics, and you'll be able to sing along with that. That should take me a good 40 to 45 minutes, I hope. And then Sam Ball, who is listening intently and ready for your questions in the first half, is going to take over and actually take you through the FizzBuzz challenge. And the FizzBuzz is a classic Python challenge. Often if you need to do a job interview or some task associated with learning Python or demonstrating your Python prowess, FizzBuzz is probably one of the most classic questions you could be asked to do. Okay. Yeah, weirdly, Joe Allen, Python and R hello world code is identical. If you are an R aficionado, you're not going to see a whole lot of difference. A lot of the syntax is same. There are some key distinctions. but we're not going to cover those today. People do keep asking me about R, so maybe one day we'll have an R session. I do teach R as well. Okay, so let's go back up to the top. Actually, before I do that, there is stuff down here at the bottom. This is the one we did last time. I've actually left all the code in here. So this is kind of an instructional code breaking thing we did called The Eagle Has Landed last time, where we actually encoded and decoded secret messages. Silly, a fun exercise. I think that the challenge, they had quite a silly answer to it. I can't remember what it was. And also we had a look at the amazing Gutenberg project, which is a guy who has just taken classic novels and turned them into text files and put them on the internet so that we can read them with Python. So there's a bit of textual analysis work there using Python. We're not going to cover that today, but you can go and play around with that as much as you like after today. Today, let's get stuck in. I'm going to keep, I think you can just hear the music in the background and I'll keep that going. Our aims and objectives today are pretty straightforward, to be honest, everybody. We're going to start writing Python code as quickly as humanly possible. So if you're not human, you might be able to do that quicker. We're going to meet some like-minded people, and I'm already overwhelmed by the incredible, I mean, the most exotic, like Malaysia, India, just like the most exotic compared to where I am right now, everybody. I love Liverpool, but it's a horrible grey day here today. So I'm for all those people who are in the tropics, I'm jealous. So I hope in my mind you are on a beach right now with a pina colada in your hand, typing code. That's what I want, right? And our third objective here is to have a bit of fun because God knows we need it, right? Our resources for HiPy. HiPy is an organization that has been running for about 4 years. It started at the University of Liverpool. It was founded by myself and Senior Sam Ball, who is listening. And it was really a response across from across the university to what we perceived as a huge deficit in a skills base for coding. You know, our students really didn't know how to code. And I at the time I was working with postgraduates mostly, and these are first class students doing PhDs, and they couldn't write a line of code. So I thought that was unforgivable. So that's why we started it, and it's kind of snowballed from there, really. I'm just reading what Joe's saying there about career prospects. I mean, he's talking about other languages as well, but the bottom line here is, folks, you're here because you know learning to code is going to increase your employability. It's probably one of the biggest things you can do. There's nothing new to code, really. You know, we've been coding computers for a long, long time, but it's increasingly employable. You know, you look at the platforms that we're using. You look at the big tech giants. They've got armies of coders, and the turnover there is massive. But beyond that, of course, data coming out of every hole, right? Is, you know, we really need to be able to handle that and get a handle on that in the future. So this is why we're here. Okay, now we're not going to do much data science today. We're just going to get the ball rolling. But I am going to promote a data science event that we've got coming up next month. Why are we using Google Colab? So good. So I've seen a couple of people saying already that they want to use different editors and things like Py. I think I saw PyCharm there. That's absolutely fine. If you've got an instance of Python running and you want to use an editor for that, that's absolutely fine. We're going to do it in Colab today, just because, as I said, it's going to run in everybody's web browser. Okay, and we can code along now without anybody having to install. If you do want to install Python on your computer or laptop, then I strongly recommend, from a beginner's perspective, you go and take a look at anaconda.com. That's a big, quite a heavy sort of distribution of Python, but it will come with a lot of bells and whistles attached, which means you're not going to have to keep installing things afterwards, and it'll get you pretty well set up. I actually installed it the other day, and it was about 0.5 GB. So it wasn't small. It's probably going to take a little while to download and install, depending on your connection. But you can get up and running there. And then you can use things like Jupyter Notebook, or I think Spider is the default IDE there. But I think they've got a link to PyCharm too. Okay, so programming basics. Oh, the one thing I didn't show you as well was we've got our Spotify playlist, which you can always contribute to. I've gone for a bit of a two-tone theme today. I've listened to the news this morning. They've got a new exhibition at a museum in Coventry. I studied at the University of Warwick, which is why I know Coventry really well. So I've got a lot of specials. I love the specials, a bit of madness in there. So if you've got anything, it doesn't have to be two-tone. If you've got anything else, just click on that link there and chuck anything you want in there. I'll keep it going throughout the session. I can just cheer it. If it's too loud or too quiet, just let me know, I'll turn it up. We've got our Padlet. So the Padlet is great. Let me just click on this, because if you've got, this is the stuff we were doing last session, but this is always a good point to share any resources that you have encountered or that you're using, you think are great. I really encourage you to share something you're currently working on or you're looking at. I'm going to put a couple of books up there later, a couple of my faves. But if you've got a resource for Python, there are so many, right? It's almost impossible to know where to start with Python. But if you're working with something at the moment, stick it in there and share it with the rest of us, and that will be of huge benefit, I'm sure. The other thing I wanted to show you, which I can see people messaging on already, is our Slack workspace. So if you click on the Slack link, that will take you through to our Slack. In fact, I've already got it open, so let's bring it up over here. And there you go. That's what that looks like. So I can see a few messages in there. Let's go to the general channel. Things are going down in here. Yeah, so I think Jokes was making a really good point here. It's just difficult for us to pick up on all of your questions on the Zoom chat. So if you've got anything you really want an answer to, because it stores it as a thread in Slack, it probably goes, oh, that's a bit weird. Slack, no, okay, I'll give you the link to Slack. Let's do that first. If I go to that and then invite people and then click on that and then get rid of that. If I post this in the chat, on the Zoom, you'll be able to link it up from there. And I'll edit the one in the document later. So you can join the Slack from there. You can always come back here anytime you like and just have a chat. If you want to ask about anything you're working on and you need to get in contact with someone quick who knows a bit of Python, that's what the Slack's for, okay? Okay, right, today, let's get started. Let me find that again. Right, I am going to start by checking out our basics tutorial here. So if you click on the link which is basics, we've got a GitHub which basically has a load of pre-written guides for Python. In fact, these are a couple of years old now, 2018. Wow, this is pre-COVID, guys. Right. So I'm going to work through this and I'm going to get you to sing along. So get your fingers warmed up and we are going to start from absolute scratch. Yeah, sorry, I can turn the music down. It's difficult. I haven't got a mixer here, so let me just turn that down a bit. There you go. Yeah, let's focus, right? I'll keep it just there in the background, just for a bit of a vibe. But it's time to focus, right? So I'm going to drag that over there. And the first thing we're going to do, right? So the good thing about Jupyter Notebook, I'm going to get rid of my table of contents to begin with, just so you can see it a bit more on the screen. Each one of these is a cell, and I've got a couple of options. I've got this is a text cell here, text, and I've got a code cell. Now I can add if I click the plus code button, which I urge you to do, you'll be able to put in something that you can start typing into. If you haven't done so already, you'll have to go to File, Save Copy in your drive, and then you can start typing. And the first thing I want to do here really is define a variable in Python. Now, a variable in Python is anything you want it to be. So I'm just going to use the words my variable, okay? And if I just run that, thinking about it, it's disconnected itself, so it's going to connect itself again. I'm going to get an error because Python has no idea what I'm on about right now. But if I go my variable equals 30, and I can press Shift and Enter as a shortcut there as well, it's done something. It hasn't given me an error this time. And if I add another cell now and type my variable again, oh, something's happened here. It's popped up with a little blue bar that says it's variable, recognize my variable. And if I run that, it will actually output that variable. So I have just stored the number 30 in a variable called my variable. Okay. Now Python's really clever at doing this. It uses what's called dynamic typing. So Python knows that that number is a number. Okay, because there are lots of other data types in Python. In fact, if I put the word type around this, type in a bracket, close the bracket around that, and press Shift and Enter, it will actually spit out the word int, okay? Which means Python knows that that number is an integer, okay? If I had 30.2, I rerun that again, and then run that one again, then it spits out the word float. And the word float there refers to floating point notation, which is essentially how you store a number which isn't an integer in any coding language. So Python has recognized that that is a float. I could have done something else. I could have done my name, Robert. I don't know why I wrote Robert. I never call myself Robert. And my mum called me Robert when I've done something wrong. There you go. Now it's spit out str, which means string. So it knows that anything in quotation marks is a string. Okay. There you go. So we can do some funny stuff with these variables here. So the good thing, let's create some more variables. Let's create one called apples, right? Let's keep it simple. Apples. And how many apples do you want? I'm going to have 4 apples. Okay. And I'm going to create another variable called oranges. And I'm going to have, let's say, 6 of those. Okay. So if I run that, Shift and Enter, nothing's happened, right? I could rewrite the word apples and oranges there. And it would just print out those numbers. What if I wanted to figure out how many apples and oranges I had in total? Well, let's add another code cell. It's pretty straightforward. Apples plus oranges. There you go. I've got 10. That makes sense, right? I could also have done it this way. I could have created a new variable, apples and oranges equals apples plus oranges. And that's really useful. Notice, okay, let me deliberately spell a word wrong a sec. And okay, there you go. If you get a red error like this, that's called a name error because I spelled orange wrong and it says name orange is not defined. It's because you've got a spelling mistake. So you get used to those. But now what I've done there is rather than just print it out, I've defined a new variable with the total in, which I can use as many times as I want. So I won't have to keep writing apples plus oranges to get that answer. Okay. So what else can we do here? Well, let's try something a bit more imaginative than that. Let's try and print something out to tell someone how many apples and oranges I've got. Okay, so what I'm going to do here is I'm going to use what we call a print statement. I did this one first, so I'm going to write print. Earlier I did hello world, classic first Python line. What I want to do now is I want to say I have, okay, and then I'm going to put a comma, and then I'm going to put apples and oranges. Then I'm going to put another comma, and then I'm actually going to put in the string apples and oranges. Okay, and if I run that, there you go. So it's printed out that string, the first string I have. Then it's printed out the number of apples and oranges, and then I put apples and oranges on there. Okay, and that's one way of doing it. The other way I could have done that is a bit more complicated, but I'm going to show you anyway. So I could have used, you see this a lot in Python, put a curly bracket, a 0, and a space. And what I'm going to do there is I'm going to put all of that in quotation marks, and then I'm going to put a dot at the end, and I'm going to write format, and then I'm going to put my apples and oranges in there. And there you go. That gives me the same result. That's the posh way of doing it. Okay. And I could also have put any number of curly brackets. And so the next one would have been a 1 somewhere else. If I got more than one variable I want to add to a string, I can add it. I would just put a comma, put another variable here. Okay. Okay. So how's that so far for speed? Are people hanging in there? Are people typing this in as they go along? Bit slower, that's fine. I have a terrible habit of talking fast. Okay, so the next thing, okay, if you're still struggling to type it in, then that's okay. If you've got the link, I'm going to put this link to this again, just in case people have missed it. That's in the chat there. If you click on the link that I've just posted and you go File and save a copy in Drive. Now you will need a Google account to do this, but if you save a copy in Drive, you will be able to then have your own personal version of this document, which you can update. If you still can't do that, that's fine. Everything else is going to be, you'll be able to get access to this link, and you'll be able to type that in at any time you like after today. Okay. Right. So let's go back to what we were talking about. Well, we've got other kinds of data as well, right? So let's consider something a bit sexier than a simple string. Okay. Let's create a list. Okay. So a list in Python is it's anything stored as a list of variables. And although those variables don't have to be the same type, they can be a mixture of strings or integers or floats, or they can even have you can have a list of lists as well. Marie is asking a really good question there. Will we be able to rewatch this session so we can review? Yes, I'm recording it. So I'll be sending out the link to that via the email that you use to register for this event after the session. Okay, thumbs up, Maria. Right, let's talk about this list a bit more. Now a list in Python, let's call it my list, is defined in a very, very specific way. We're going to use, and these guys are going to be your ultimate friends, we're going to use the square bracket, the good old square bracket. And that really is a massive workhorse for Python. Most objects are going to be lists. Well, personally, I do a lot of data analysis. I've got lists, up to the eyeballs. So I see a lot of square brackets on a day-to-day basis. Okay. Now, all I have to do there to define a list, let's just define a list of numbers. Let's do 1 to 5. I can do 1, 2, 3, 4, 5. And if I run that, okay, and if I put another code cell in there and rewrite my list, I can run that. And that's what it looks like. Now, I can do a few funky things with this. They don't all have to be integers. So I could put a string here, or I could put a float, or I could even put something like this. So that's so this true, or I could put false as well. That's a very specific data type in Python again called a Boolean or a bool. And that can only take values of true or false, or 0 or 1, depending on how you're processing that. Okay. And if I run that again, it prints the list, and it will give me every element of that list. Okay. Now, once you've got a list, there are certain things you might want to do to it. You might want to just get one element of it. So let's say I want to get the first element of that list. Let's say I just want to pick on the first. If I wanted to call that in Python, I do it like this. Oh, I'm not going to, oh, you thought I was going to press a 1 then, but I didn't. I'm going to press a 0. Okay. And if I do that, it'll spit out the 1, right? Now that is probably the most important thing I'm going to tell you today. or at least in the next 10 minutes, right? In Python, when you store a list, the way it indexes that list, the way it counts, this is the first item, this is the second item, this is the third, it starts at 0, okay? And that is, so we were talking about R earlier, that's a key difference to something like R, which actually starts at 1. So for us, we're going to start at 0. If I wanted the third element of that list, so actually, say I wanted the 3.06, that's going to be 0, 1, 2. So I would need to put a 2 in there, and it'll spit that out, okay? Now, here's a really interesting thing. In Python, you can call any item in the list, but you can go in the negative direction as well, right? Let me just show you what I mean by that. If you don't think that's exciting, it is, okay? Instead, if I say I wanted to call the last element of the list, right? Now, if I just wanted to get this false value out here, I'd go 0, 1, 2, 3, 4. Simple as. In fact, I'd do that just to prove it. I get the false out. Now, what would happen if you didn't know how long a list was, or it was a dynamic list that was constantly updating? I just wanted to get the last value out. Well, in Python, I can go in the opposite direction, and it will come back around on itself. So I can type -1, right? And what that does is say, well, it's not 0. I've got to go back round to the last value and print that out. So that's some really cool functionality in Python. That's gotten me out of a lot of tricky scrapes. Just by, if I really need to know the last element of a list, I can get it that way. Other things I can do with my lists, I can add something to it. So if I wanted to, let's say I want to add a new value, let's do mylist.append. So I use the .append function. Actually, that's wrong, isn't it? That's Python 2. So I'm going to do, yeah, I can do that as well. Let's say I want to put another value on my list. Let's say I want it to be a string, another item. I can do that. Start a new code cell, my list. And there you are. Let's put that other item onto the back of it. Okay. That's a really good question about from Kian there, is why is false fully capitalized and true isn't? True is. Well, okay. So it is capitalized, but it's important that you recognize that it is capitalized, because if it's not, it won't be a true value. It won't be a value. Well, this, I'll get an error, right? If I do that, it's actually, if I've used a lowercase t, it's actually looking for a variable name. If I have, for whatever reason, done something crazy like this, it'll be totally fine with that. But why would you do that? Okay. Okay, let's move on a bit. Another useful thing to do with a list, in addition to adding something to it, is you might want to select a sub list. You might want to have a, what's the word I'm looking for? A subset from that list. Okay, let's say instead of the full list, I just want all the values after the third item. So there's 1, 2, 3. I don't want the first 3 items. I would like everything else. So 1, 2, the last 4 items there. So that's 3, isn't it? Sorry, that's the 4th, the 5th, and the 6th item. So if I wanted that, I would go my list, and I would open up a square bracket, and now I'm going to slightly call it slicing, list slicing. I'm going to slice this list up, right? I'm going to start at the index, which is 3, because that will be the true, and I'm 0, 1, 2, there's the third item, and then I'm going to put a colon, and actually that's all I need to do for that. I can press Shift and Enter, and it will print out those. Oh, it hasn't added that. It's because I took it off there, right? So let me get rid of that one. I reran this line, which is why it took my last element off there. So it's only printed out the true and the false from that list. Or I could have done the first 3 items. I could have done colon to 3. And that will give me the first 3. So that's really useful sometimes if you want to subset your lists and create new lists based on what you've got. Okay, you can always figure out what the length of a list is as well. Let's do that by typing len, open up a bracket, just a normal bracket, and then we're going to write the word my list. Shift and enter, and that will tell you that there are 5 elements in that list. Always a useful function. And that's pretty much that's it for lists, really. I mean, you can make lists of lists. You could do something like I could add, let's append a new element to my list. Let's do my list dot append. And let's do another list. And I'll do 6, 7. Oh, that's a string. I don't want, I'll add it as an integer. 6, 7, 8. And if I show you that list now, my list. Okay, now I've got all of these items in a list, and then the last element here is another list. So I've got a list in a list. And you can do that. You can go as deep as you want with that. You can have a list within a list and a list. Think of Inception, right? You can keep going. You can have these multi-dimensional lists, which, of course, if you're working with something that involves multiple dimensions, for example, if you wanted to create some position for an item that was moving through space, you would need to do that. You would have to specify its coordinates in multiple dimensions. So you might use a multi-dimensional list to do that. Okay. Right. Let's keep going. Let's do something really useful. Let's do some useful stuff, right? So let's do a bit of math. You can't escape a bit of mathematics sometimes, can you? And you should expect that if you're doing a bit of coding. And in fact, you can use Python as your calculator if you want to. That is something which, I mean, this is what it's designed to do. It's designed to do rapid calculations faster than you could ever dream of doing it yourself, right? So let's do some maths, right? We can do things like, let's think of adding 2 numbers together. 1024 plus 4568. There's the answer. Or I could have subtracted them. There you go. I could have done a multiplication. There you go. Or a division. And then you can get really jazzy things. So I could do a double star, and that will give you 1024 to the power 4567, which of course is a ridiculously big number. I could have done, in fact, let's make these numbers a bit simpler, right? I could have done 105, and I could have done modulus of 6. Okay, so what's happened here is this percentage sign, what it's telling Python to do, it's saying divide 105 by 6 and just give me the remainder. Okay, I don't care what the answer is, just give me the remainder. Okay, or I could have done // and it would have told me how many times 6 goes into 105 without the remainder. Okay, so lots and lots of maths you can do with that. I mean, that is the most fundamental stuff I'm showing you there. But usually these days, I used to have a pocket calculator somewhere. I don't know. I just open up a Python console and I use that as a calculator. And you can do, you can do everything with it that you would do on a scientific calculator. You can use trigonometric functions, square roots. I've even got all the symbols I need using the math packages. In fact, that brings me neatly on to a concept of importing modules in Python. Okay, so I'll tell you what I'm going to do. I'm just going to pause for breath, and I'm going to ask Sam how he's doing. Sam?
Yep. Hello.
Are you fielding questions elsewhere?
Yeah, we've got good questions at the moment. Yeah,
lots of good fantastic questions. So is there anything that I need to address right now, Sam, that I haven't picked up on?
At the moment, it's just about how you're running your cells. So it's just Shift plus Enter on a Windows or Command plus Enter on a Mac.
Yes, thank you for clearing that. So that saves, it's amazing how much time that saves. So instead of clicking the plus button here, which will always work, in fact, you might not be able to see that on your screen, but you can press Shift and Enter or Control and Enter, and on a Mac, it'll be Command and Enter. I have a question about :3 and 3 : that was from, I've lost it already. That was from Karen. Was that the list slicing above here? Yeah, so what we're doing here is we're opening up those square brackets, and I could have done like this, 1, 3, and that's going to print out all of the elements that are between 1 and 3. So you can see here, this is 0, so it's left that one off. There's my first element, and it's gone 2 and 3. And actually in Python, it starts at the 1 and it goes up to, but not including the last one you specify. So if you wanted to have the true value in there as well, you would have had to do 1 to 4. I hope that makes sense. There you go. I get some good questions there, Sam. I'm gonna let you dive back in there and answer a few of those. I am going to move on to importing modules now. What you're dealing with, what we are just touching the tippy most tip of the iceberg here, folks. Right? I think what we've done here, if you've managed to follow along so far, this is a huge thing. What you've just done is amazing. You've asked the computer to do something for you, and it's done it. Okay, and that is it. That is really as simple as it gets. Now we're going to ramp up the complexity here by considering, all of the massive universe that is Python. So beyond what you have within this browser, what is currently there, and all of these commands I'm running, we call those native commands. So everything I've just created here, string or the list slicing, that's kind of all default when you open up one of these windows. But the way Python works is you have all of these libraries and modules full of code that people have already written, right? So if you're having to write something complicated, or if you've got a specific challenge that you need to use a bit of code for, the chances are someone's already done that for you. And the chances are as well, they've packaged it up into something really neat and tidy for you to just use it with a single one-line piece of code. So a really, really good example of that is something like NumPy. Okay, so I'm going to show you what NumPy. Let's import a module. Let me put a little hash mark. I'm going to put a hash mark there, and I've done that for an important reason. Anything in Python, any cell or any line you write in Python that starts with the hash symbol is what we call a comment. So that will allow you to write anything you want at that point without Python compiling it. So I could write the moon is made of green cheese right there, and Python's not going to care. So anytime you want to document something you're doing, and it's important you do that because you might not be the only person that reads that code. Sam Ball is laughing at me right now because I never comment my codes, and he's the poor sausage that has to read mine usually. But get into the habit of just putting a brief note. If you do something a bit tricky, put a comment in and write a little note about it, okay? So what I'm going to do here is I'm going to import a module, and I'm going to import a module called NumPy. Let's do that. Let's import NumPy. Okay. Now people are going to yell at me when I do this, but I'm going to write Shift and Enter. Okay. Nothing really happens. Something has happened. It's just basically gone to a repository or folder in it's, this is online, so it'll be on a server somewhere. If you're doing it on your computer, it would actually be calling files off your computer and getting them ready. And it's imported all those. So I can now use any function that is written in that NumPy module. Okay. Now I've written it simply as import NumPy, which means if I want to use any function in there, I've got to do something like NumPy dot. Okay, that is how I would do it. And actually, if I do that, Colab automatically brings up a load of stuff. And what these are all of the functions or methods, I should say, associated with this module. Okay, so if I wanted to, in fact, where is it? Let's see if I scroll down. I'm not going to find it in there. If I just wanted to print out the number pi, okay, and numpy.py, Shift and Enter, there you go. It prints out pi to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 decimal places, okay. I didn't have to leave the line. Zainab, I did it because it just makes things a bit easier to read. It's a bit neater and tidier. Okay. Yeah. Thanks, the Oracle. Well, you should know what you're talking about is the Oracle. Okay. Now, this is if you ever. If this has happened to me, right? I used to do this for years, and then I went to a meeting and I was showing some of my code, and they went, "Oh, why have you written NumPy like that?" I was like, "Well, what do you mean?" It's like, "Well, why don't you do it like this?" And I was like, "Okay, why would I ever do that?" But what it means is that every time I want to use a function in NumPy now, because I've said this as NP, I don't have to write the whole word out. I can just write NP and it'll do the same thing. It saved me 3 characters, okay? But if you've got 10,000 lines of code and you need to use one of these functions on every 10th line, every 3 strokes that you miss out is going to be a lot of time shaved off, okay? So that's the convention. And in fact, it's convention. If you're going to write, especially if you're a scientist or you're doing a bit of research, and you're doing a bit of data, probably one of the first thing you're going to import is the NumPy, and you're going to do it exactly like this. Import NumPy as NP. Okay, you could import it as P. Yeah, I'm seeing Joe Allen there. So you could have it as a single character. There's no problem with that either. But by convention, we use NP. Do whatever you want. Oh, NPN. Okay, there you go. Okay, let's do something a bit more exciting with this NumPy package, right? Let's say I wanted to generate a massive list of numbers. Let's say I wanted like 0 to 1,000. It's not that massive, but I didn't want to have to go x equals 1, 2, 3, so on and so forth. I just wanted all of those numbers. Then there's a function in NumPy that allows you to do it. So I'm going to call a function from NumPy, np dot, and there's loads of functions to do this. I'm going to use what's called the linspace function. Linspace, and you can see Colab's found it there. And now it's a function, right? So I'm going to open up a bracket, and I'm going to tell this function that I want to start at 0, and then I'm going to put a comma. I'm going to finish at 1,000. Okay, if I run that, in fact, underneath I'm going to do print X underneath as well, so you can see what this is going to look like. Shift and enter, and wow, look at that! I have got one. I'm not going to count them all. Actually, has it given me 1,000? Okay, it hasn't given me. It's given me 0 to 1,000, but I think it's only given me. And let's figure out how many are there. By default, it's only given me 50 values. I didn't want 50 values. I wanted 1,000 values. I wanted 0 to 1,000 in increments of 1. Okay, so by default, it's given me 50. If I wanted the full 1,000, I would go comma 1 there like that. Okay, let me change that line to print it out again. Shift and enter. Done something wrong. Let's figure that one out. Maybe it's going to be 1,000 for 1,000 values. Yeah, that was what I need to do. So I need the third item in there had to be how many values I wanted. So there you go. I've got 1,000 values from 0 to 1,000. And the reason why they're decimal places here is because I've included the 0. I should have done 1 to 1,000. There you go. And then they're nice round numbers, okay? So that's a massive list there. If I've got something like that, and I've got my list now in X, so this is just a huge list. You can see it's a list because it's got a square bracket there at the beginning. I can see a question there from Alifia. What is np.linespace? Okay, so look, this np linespace, just to go over that again, is a function we're using from the NumPy module. So we've imported the module here, import NumPy as np. Batul, sorry, Batul. And what I've done here, I've called the module using np, and the dot is basically me telling Python, get ready. I'm going to use a NumPy function here. And then I'm going to call linspace. And linspace, if you actually hover over it, you'll get a bit of information on what linspace is. So it tells you here, you can see on the second line of that, it says def, linspace, start, stop. So you got that num, the default is equal to 50. So those first three there, you put in your start value, which is where you want your list to start from. Your end value, I wanted it to be 1,000, and I wanted 1,000 values in there. Okay, so that's what the linspace has done. And that means we don't have to type all those values in by hand. My code is identical to Robert's, but I get common numbers. Aha. If you put X and run it, you might get commas. Yeah. So the only difference I suspect there, Alexandra, is I used a print statement to print it out. I went print X, and you've just typed X. So yes, the commas do signify that it's a list. Okay. Let's do something a bit jazzy. Let's calculate another variable, Y, which is dependent on X. Let's do X squared, right? Let's do X to the power 2. And then if I do print Y this time, it's printed out 1,000 values, but it's printed out a value of X squared for every value of X I've got. Okay, you can see that, you know, once you get to 1,000, 1,000 to the power 2 is 1,000,000, right? And that's what this notation is saying here. So it's 1.000, and the E plus 06 is essentially computer notation for 1,000,000. It's a 1 with 6 zeros after it. That's how you denote that. Okay. Right. Let's go back at the top. Okay, so that's nice. I can do some calculations, but what if I wanted to print that out as a graph? What if I wanted to visualize that in Python? Well, oh, that's got my head scratching now. So I've got another module for that, folks. It's called Matplotlib, another Python favorite. So very often you'll see import numpy as NP, and the second thing you'll see is import matplotlib .pyplot. That's the distinction there as PLT. So okay, I've just said a whole load of stuff there, right? This is what we're going to do now. I am going to plot a graph of X versus Y. Okay, so I'm going to have an X on the X-axis and a Y, and I'm actually going to plot this X squared on it. So it should be like that for a squared graph. Okay. So I'm going to start a new cell. I'm going to get rid of that output to begin with. Start a new cell here. And I'm going to import another module in Python called import matplotlib .pyplot. I'll explain that one in a second as PLT. And I'm going to shift and enter on that. Now, this import statement here, I've done import matplotlib.pyplot, and that's simply because this matplotlib module, if you think about it organized in terms of folders on your desktop or whatever, I've got my matplotlib folder, okay, and now all of the useful functions are actually arranged within that in subfolders, okay, and the function the only sort of folder I want to import is the one called pyplot, which for us essentially is a plotting folder. There are other functions, but in fact, I've never used anything outside of the matplotlib.pyplot folder. Okay, so rather than we have to call that function every time by doing matplotlib.pyplot.plot, I've imported the whole thing as PLT. So I can just do PLT.plot and it will print something out. So to make that plot, all I've got to do here is PLT.plot. I'm going to put my X variable in first, X, comma, Y. And there's this one sneaky little thing I've got to do afterwards. I've got to do PLT.show. Okay, so this first line here on line 3, it generates the plot, but it doesn't automatically spit it out. It doesn't print it out for you. And what the PLT.show is doing here is it's telling Python, right, take that plot that you've just created and give me a visualization of it. So if I shift and enter there you go. That's X on the X-axis and then Y. So that's the graph of X squares. Okay. Yeah, plot show. That's a good point, actually. I think plot show, it does still run as well. Yeah, that's fine. You can do it either way. The reason I put it is technically a function. So that's why I put the brackets on it. Okay. I think that might catch you out if you're using some other editor. Okay. Right. So what you've done here, incidentally, is great, but there are a few cardinal sins here, folks. And I, as a maths teacher and a physics teacher, I would not let this slide. Okay. You need what do you need, folks? You need some axis labels in here, right? I need to know what I'm looking at. Okay, it's only X and Y, but it might be something useful. It might be population of this. It might be time. Okay, so I am going to add a couple of labels here just by doing plt dot x lab x label equals x, plt dot y label equals y. I think that might need to go like that, actually. I always forget these. Oh dear. Right, I have forgotten how to do this. Sam, can you help me out here? Because I've forgotten how to add X labels. Yeah, I'm going to wait for Sam to do that one. So actually, I'm not going to wait for Sam. This is what you're going to do. If this ever happens, right, you go to Google, and I do this 100 times a day, and I say add label to PLT matplotlib. Just type some relevant terms in there. Add labels and text. Yeah, let's try that one. Yeah, Sam's already told me the answer. There's a couple of ways you can do it. That doesn't help me, does it? I'm determined to find it now. So this is what coding is like, folks. You spend half your time trying to answer a question that you have by Googling, and that is totally fine. Now, Sam's already told me what this is. So this is set X label, I think. Oh. Sam, you're gonna have to jump in here, I think. Right, I'm gonna move on.
I'm not actually sure what's going on there.
Yeah, I don't know what's happened there. She usually does it, right?
Yeah.
Let's go back there and make sure that's right. I did it earlier. plt dot set. I thought this was xlab. Yeah, don't know what's going on there. So we'll figure that one out and we'll put it in the notes so you can watch it afterwards. It should give suggestions, shouldn't it? Right, there was one last thing I wanted to show you, and that was a worked example, right? So what I was really hoping to do here is show you how to create, let's have a look, this graph. Okay, now we're a bit tight on time here, folks. So what I've done is I've prepared an answer. So what we'll do is I'll post the answer and we'll take a break, and I can see you got the X labels on there, and we'll see if you can reproduce that in either in your own time or in the break. So this is a graph. It's not very easy to see here if I zoom in a bit. It was just a simple graph of sine X versus YX. I've used a combination of NumPy and Matplotlib to do it. All I've got to do here, I think, just have a look over here, bear with me, is give you the code to do that. And we'll talk it through afterwards, okay? Right, let me zoom in again. Right, the challenge here, oh, come on, computer, don't fail me now. Oh, Sam's put X label, yeah, that's right, that's what I wanted. The command I was using here was X label, X, and then plt.y label. Well.
So this is actually working for me right now. What you've written,
yeah,
is actually working fine for me. I don't really know why it's doing that.
Strange. Let me try my next. So I've got the challenge here. and I'm going to paste.
Oh, have you spelt label wrong? No.
Yes.
Yes.
Yes, I have.
Good. Shout out to J for that one.
How do you spell label?
That's how you spell label.
That is how you spell label,
yeah,
isn't
it
it?
is, but I think it's somewhere else you've spelt it incorrectly, I think. Okay. Yeah. I don't know what's going on. That's literally working for me. I've written exactly what you've written.
Yeah, yeah.
Is it not quotation marks, but single quotation marks?
That shouldn't make a difference.
That shouldn't.
Yeah,
No,
weird.
Yeah, very weird.
I tell you what, we'll move on. We'll figure that one out later, folks. See, it's not all plain sailing, right? Maybe it is how I define the X and Y values there. You're right.
Yeah, it seems like it's working for almost everyone apart from you. So
yeah.
Okay. That is the correct. Just for the record, that is the correct syntax. That is
what I'm going to do is I'm going to post. So I really would have liked you to have plotted that graph. So here's my. Oh, I'm ringing a sec here. Cancel that. I'm just going to. There you go. Sorry, folks. Give you a load of codes because we're running a bit behind. And there's that graph. Now, that was a really mean thing that I just did, right? Is I've given you a load of code without explaining it, okay? What you can see here is I've used that linspace command. This time I've defined a range of 0 to 2 pi. Okay, that's NP pi there. And I've asked for 100 values. Now, I've generated this plot here, again, using matplotlib and the PLT, but I've defined this figure object and this axis using this additional function here. You'll see this all the time when using matplotlib. And this time, I've done exactly the same command essentially, but I've used ax.plot instead of plt.plot. And the reason I've done that, it's a bit more formal, but it gives me a bit more freedom to change and manipulate that graph afterwards. So if you get in the habit of making plots on a regular basis, I recommend doing it this way. Because you can do things like change the size, change the font size, change the colors, add legends, and it will be a bit easier. And you can see I've got a completely different function here for set X label, which has worked. Oh, don't know why it didn't work above. And the other really useful thing is you've got this fig.savefig, which means that if I run that, it'll actually save the image that I've created as well. Okay, so I think we should take a break, right? I think that's a good point. Before we do, let's have a 10-minute break. That'll give Sam enough time to work his magic in the second half. I just very, very quickly want to promote our next event. Okay, so we since we've been in lockdown, we're really missing our sort of in-person events. So because we had the sort of, I hate the word pivot, but we pivoted to online, whatever. We had to think of a couple of additional events that were a bit more focused and a bit more interesting for anyone who really wanted to take take Python beyond what we were doing today. It's still an absolute beginner's introduction, kind of, building on what we're doing today. But it is a real introduction to a massively powerful Python module called Pandas, which is essentially a module that focuses exclusively on the manipulation of data, right? I'm talking about rows and columns here, folks, right? And I'm not talking about, Microsoft Excel. No. I'm talking about if you wanted to do some real hardcore filtering, processing, number crunching, stuff that would take 1,000 clicks in Excel, doing it with Python. You can strip it, stripping data off the web to get it into a format that you can do that as well. And what I really wanted to do, I think we've kind of done it, is we've got a couple of these events where we deliver all of this through the lens of a current issue, current event, right? So we've got the topic of the gender pay gap, and that why I chose that one is because I'm a university lecturer as well, and I ended up on a committee that was responsible for reviewing our human resources and our hires and fires and things like that. And there was some staggering disparity in gender on that. Okay, and I'm sure that is true of a lot of other institutions as well, but it shocked me. And that data is public knowledge. So I thought we'd have a little look at the gender pay gap, specifically across higher educational institutions in the UK and internationally. And we'll use that as a vehicle in which to learn a bit more Python. So there's the register link. You can register now. Again, it's focused on an absolute beginner for data science in 2 hours. We give you all of the resources. So if you don't get it during the session, you can either ask us on the Slack afterwards, or you can come back to it anytime you like. You can, start doing some real number crunching with Python, reading data from files, processing, filtering, sorting, and of course, visualizing. Okay, and that Matplotlib is really heavily entwined there as well. We're going to use a real data set that's publicly available. It's actually on uk.gov, or the government website, and we'll do it there. So if you're interested in that, like the sound of that, please register. That's on the 3rd of March. So springtime, right? So please join us for that. Right, we're going to take a break there. I'm going to stop talking because I do that far too much. And then after the break, we'll have 10 minutes. We'll come back at 5:15 if that's okay. And then Sam is going to lead you into the world of FizzBuzz. Is that okay, Sam? I think he's gone for his cup of tea already. I'll put the tunes back on.
Sorry, 4:15, just to...
Oh, yeah, thanks, Sam.
Yeah.
I don't even know what time it is. 4:15. I'll put the music back on and I'll turn my camera off. There you go.
You keep on giving me the hold up. You know I can make your mind up. 'Cause when we get on so, you used to be my Romeo. 'Cause you seem like, yeah, I have had enough of keeping quiet about all this stuff. You're new rockin' like a yo-yo. You used to be my Romeo. Let it all go. Let it
我是不养你那，我你说，我也不想。
Okay, we're back. I can see Sambo, who I keep forgetting has bleached his hair blonde. Right, Sam, you okay? You ready?
Yep, I'm
Right.
ready when you are.
So before you share your screen there, I'm just gonna draw everyone's attention to something which is kind of fun. I don't know what lockdown has been like for the rest of you, but in fact, I've got one of them yelling in the toilet now. They've just informed me that they've just done a massive poo. But I've got a 7-year-old and he's three. And we've spent the majority of lockdown, apart from homeschooling, of course, playing good old-fashioned games. And one which we've developed a massive passion for is Connect 4. And we've taken Connect 4 to another level.
Yeah.
So what we did here, if you don't know what Connect 4 is, Google it. It's a simple game based on counters and trying to get 4 in a row. But what I thought I'd do is I challenge you, with your new armed knowledge of Python, to go away and see if you can build a Connect 4 game in Python. Here's a version I made. You can see it here. So the way it works is you have to put counters down a column. And I think mine are yellow and red as the traditional colors. I've used X's and zeros here as well. And the first person to get 4 in a row wins. Okay. So if you can build that in Python, that's our competition. I'm going to put a deadline on the 1st of March on that. But if you win, if you were the first person to post a working Connect 4 code there, I will send one of these to you wherever you may be in the world. It's called 4 to score here. I always remember it's Connect 4. That'll be yours. Okay. Right, Sam, I'm going to hand over to you. I'm going to man the chat now. So if you still got questions, either post them in the Slack, if you're in the Slack, or in the chat. And I'm going to stop talking. There you go, Sam. It's all yours.
Yeah, brilliant. Can you stop sharing your screen?
I've got to do that, haven't I? Sorry, folks. Yeah. Stop share. There you go.
Okay, and we are over here. Okay, so can you all see my screen and hear me as well?
Yes.
I need to get the chat up. There we go. Fab. Brilliant. Good. Fantastic. Great. Okay, so first off, I'm just going to say how you join the Connect channel, because I couldn't. You click More, you click Channel Browser, and then you click on the Connect channel, and that'll join the Connect 4 competition, and then you'll be able to type in it and submit your entries. Okay, right. And then I also got asked what our Twitters are. The fastest way to reach us with all our HiPy events and stuff is probably the HiPy Live Twitter, which is this Twitter. Then we also have, let's move this over here. We also have Rob's Twitter, which is @RobTrahan. So that is that, and then there's mine, which is @STMBall. That's mine. So I'll just show how to join the Connect 4 channel again. You open up Slack. If you join the Slack channel, then you click More, and then you click Channel Browser, and then you should be able to join the Connect channel from here. It's a little bit hard to find. So More, Channel Browser, and then Connect, and then people should start posting in there. I can hear it already. Fantastic. Right. Okay. So then also something that we always get in. Can everyone hear the Slack notification, by the way? Do I need to? I'll just leave it. Okay, sorted. Another question we also have all the time is how can people practice their coding knowledge? I would say the best way to learn how to program is choose a project and just try and learn everything around that project and try and achieve your goal. That's ultimately going to be how you learn coding, just by doing kind of thing. However, a lot of the time, a lot of people say, I don't really know what I want to do. All the projects I look at are a little bit too advanced. And if you're in that position, I've got two great websites for you. The first website is a website that we used to use very early on in HiPy called Check.io. This website, if you click on Python, you'll have to log in, but I've logged in already. And it gives you loads of challenges to do. So if we go to home, there's like loads of different challenges that we can do. So we can press some numbers. It'll open up an environment. Basically, the challenges where you, am I not sharing my screen? Only see the Connect 4 screen. Hang on. Should be able to see this.
I can see a Connect 4 screen, Sam.
Okay, hang on. Something's gone wrong. Can you see this now?
Oh, give it a second.
Should be on a web browser.
No.
No, it just says Samuel Ball has started screen sharing.
Wow. Black screen.
Gremlins today.
Yeah, very. What about this? Does that work? Has that showed my web browser?
No, I can't see anything.
Okay.
Says to double click. What does that mean? Black screen. Yeah,
Let's
that
stop.
doesn't happen.
And then let's try starting again.
I'm not doing something silly, like still sharing mine.
I think so.
No. Ah, okay, we can see stuff.
This is the web browser, right?
Yeah. Okay.
Okay.
Right.
So I'm now just sharing my.
Sorry,
web browser
I should
to my
have
desktop.
cottoned onto that quicker. I wasn't paying attention at all. Right. Sorry,
Okay.
Sam. You carry on.
So I'll go back a little bit because you can probably hear my Okay, so I'm putting this in the chat. First website for coding practice is Check.io. You click on Python. You'll have to log in. I've already logged in. Then there's loads of different challenges you can do here to practice your Python. So this one says we need to sum the numbers in given text. We can do that. If you click solve it, it'll then send you to a nice development environment that you will write your code in. So that's option one. The option which I really like is Code Wars. So let me just copy this in. There we go. And you can sign in with whatever you want. And then this is like challenges which are determined by skill level and how kind of like how confident you are with Python. So it's I think it's Carter of the challenges. 8Q is the easiest challenges right the way up to 1, which is really, really difficult. And they've got loads of programming languages here that you can do them in. So this is good, a good resource for any programming language that you're doing. I think I can do around about the level 5 questions, but I haven't really spent any time doing the harder questions. So that's good. Okay, right. We'll close this down as well. Oh, yeah, the Twitters was at HiPyLive, at STMBall, and at Rob Jahan for our Twitters. I'll post them at the end of the session. Okay, right. So one of the really common problems. So back to the notebooks now. One of the really common problems for on these websites is something called the FizzBuzz challenge, or just FizzBuzz in general. And this was a interview question, quite an old interview question, perhaps for older programming languages, where basically you want to write a program that takes the numbers from 1 to 100. If the number is divisible by 3, it outputs fizz. If it's divisible by 5, it outputs buzz. And if it's divisible by both, it prints FizzBuzz. So we're going to do that now, and we're going to keep on like abstracting and making our program more and more powerful, basically until we run out of time or I run out of resources, and then we'll go on to a challenge for everyone. And we're going to learn loads and loads of Python throughout this. We're going to do like loops, control logic, all kinds of things. We actually might spend a hell of a lot of time on this first cell because we're going to be doing a lot of new and lots of very powerful stuff just in the kind of like version 1 simple version of this problem. So in the notebook, I've actually got loads of comments here for what we're going to be doing. So no matter how far we get, you should be able to do a little bit of work just from the comments. But really here, Google's your best friend, and you're going to kind of like want to really bang your head against the proverbial code brick wall to learn how to do this stuff. So the first thing we're going to do, I've actually gone a little bit ahead of myself here, is we're going to want to loop through our numbers from 1 to 100, and the way that is probably the easiest way of doing this is by using a for loop. And the way for loops work is they basically take a section of code, so this code that's indented, so it's moved slightly to the right, and it runs the code for every basically value in a list. So, for example, if I said for text in and then a list, hello, comma, world, comma, HiPy, we would then print text. And what this is going to do, let me just very quickly comment this out so we're not running that. What this is going to do is we're going to take a temporary variable called text, and for every time you run the loop, it's going to treat the variable text like each one of these in turn. So each one of these values in our list is going to try that in turn. So if I run this code, it'll print hello, then it'll print world, then it'll print HiPy. Now, what I've done here is I've been a little bit cheeky, and instead of using a list, I've used what's basically a function that will give us a list. So the range function, so I'll actually show you what the range function does first. The range function takes, well, there's lots of different ways that we can use the range function, but the way we're using it is if we give it 2 arguments, the first argument will be our start, and the second argument will be our stop, but not including. So this will give us the numbers from 1 to 100. And then I am going to just put this in a print just because of a problem I think Callum was asking earlier. This is like a little bit complicated. And I'll probably make a post about this in the Slack after, but in general, you want to be printing your outputs instead of just outputting them willy-nilly. This is going to say range 1 to 101. That's a little bit of like a funny Python thing. If I just wrap this in a list function call, it'll actually just give us all the numbers. The reason for that is because the range function doesn't actually give you a list. Little lie there that I told earlier, but it gives you a list-like object. So Python treats it as a list when it's convenient. The main reason for this is because it's just a lot faster the way that Python's doing it here than just generating an entire list. And if someone wants to ask the question in Slack of how this works, I'm happy to answer it, but it is quite a complex question. So I'll just gloss over, and all you need to know, this is a list-like object. Okay. So now we can actually just go to our code. I'll just do the following just to say that it's working. So here we're taking each of our numbers in this list. So we're going, okay, number equals 1, print the number. Number equals 2, print the number. And we're doing that all the way up to 100. So we can scroll this down and we get the numbers from 1 to 100. And then just a few things just to really, really stress here. For a for loop, we need this colon here to say that this is kind of like declaring our for loop is about to happen. And then we also need this indent, which is either 4 spaces or a tab. If we don't put this in, so I'll put print hello, what will happen is we'll just get we'll just get hello 100 times, but we'll actually not get the numbers because it's what's called a code block. This print number isn't in the block that is associated with the for loop. So if instead I run this now, print number is in the code block, it knows that we're for looping over this code and we're okay. Okay. Any questions for that? Because I've just given basically all of for loops in like a minute. I'm not sure if I'm seeing the chat update, but silence seems like
I think you're good, Sam. You've done it.
I think we're
Done a
good
good
to go.
job
Okay,
of that.
fantastic. Right. Okay, because this is like one of the major powerful things about coding and why we want to code in general is because if I wanted to do this by hand for the numbers 1 till 10, yeah, I could probably do it, and it probably actually would take about the same amount of time as if I was doing it in Python. If you've got an indentation error, try using so if I'm entering this in, so I'm copying my thing down. I do close bracket, enter, and then when I press close bracket colon, when I press enter, it should automatically put you to a new tab. If you've accidentally put 2 tabs, that'll trip you up. That won't work. 1 tab is what we need. Okay, just to make sure everyone's following along. 2 tabs will come in later, but 1 tab. So here I've got 4 spaces, but the reason why it's 4 spaces is because Colab will automatically turn a tab into 4 spaces. We're going to post the recording of this after the session. Okay, so we're going to move on. Okay, now I'm going to move on to if statements. So if statements are like for loops in that they've got like code blocks and everything. But if statements are the other powerful thing about Python because we're basically able to make complex decisions based on certain things and have Python do different things based on if certain things are true or not. So that's a very like general and abstract way of talking about it, but that's kind of the whole power of it. So what we're going to do is we're going to start by saying if the number is divisible by 5. We'll go down here first. We'll do this. So actually, we'll do it in order. Okay. So the first thing to note is if a number is divisible by 3 and 5, we want it to return fizzbuzz. So we want it to just print out fizzbuzz instead of the number or fizzlebuzz. And a quick kind of like mathematical kind of shortcut here is noting that if a number is divisible by 3 and 5, that's the same thing as saying it's divisible by 15 because 3 times 5 is 15. So if it's divisible by 15, it's divisible by 3 and 5. And the way we're going to write this is a little bit complex. I'm going to write it down and explain what everything means after. We're going to say if number percentage sign 15 double equals 0, panic, what's going on, colon, print fizzbuzz. Okay, so don't panic about this. We're going to go through it step by step. This is just saying if the number is divisible by 15, I'll go over that in a minute, then print fizzbuzz. Okay, now what does this percentage sign mean? What does this double equals mean? Oh my God, I don't understand what's going on. That's fine. The percentage sign is called the modulus or modulo symbol in Python. And what this is doing is it's taking the division, so it's doing number divided by 15 and taking the remainder. And why this means if the number is divisible by 15 is because what we're asking here is saying if the number's remainder when divided by 15 is equal to 0, only then print fizzbuzz. Okay, right. You might be saying, well, why are we using double equals here to say if the remainder is equal to 0? Well, because we use equals for variable assigning. So double equals is your logical operator. So this will say if the left-hand side is equal to 0, then do the following code block. So very, very important. This is the cause of about 80% of my errors in my code is using single equals instead of double equals. It's a really easy problem to have, but double equals is your logical comparison between two things, right? Okay, but we're not done yet. What we need to do is we also need to check for divisibility by 5 and then divisibility by 3, and then we need to do all of our other cases as well. And what we can do, this is incorrect, is we could write another if statement. So we're out of this code block now because we don't want to check the if statement inside the if statement, but we still want to do it inside the for loop because we want to keep on going through the numbers. We could do it like this. We could say number divisible by 5 is equal to 0, print, and then we said 5 is buzz, whoops, buzz. And then we could write, and again, this is incorrect, if number is divisible by 3, print fizz. Now, some of you might know what's going to happen here, but if I just run it, we're just going to get a load of nonsense out. So I'll actually, what I'll actually write is I'll also print the numbers. So we'll do this, copy this down here. Whoops. Any problems? And this. Okay. And what we'll see, so this is a bit lazy in what I'm doing, but 3 is fizz, 5 is buzz, 6 is fizz, good. But then when we get to 15, we're doing fizz, buzz, and fizz. Whoops, we've got a problem. We're doing every single block. And what's happening is Python is going down here. It's checking if this is true and running this, good. But it's also checking if these are true. That's a problem because we only want it to do one of these things. And the way that you would do it usually in programming is using like an else if. So I think in JavaScript, you would write this. You're saying that if this isn't true, then if this is true, do this. Otherwise, if this is true, then do this. Otherwise, and then you do your other things. Python is slightly different. It's just called elif. So we change these to elif. We run this, and we should see that in 15, we only have 1 entry. Fantastic. But we're also missing all the other numbers. So at the end, when we get to the end, we need to catch all of our other things. So we're saying, if this is true, else if this is true, else if this is true. Our final thing, and it's always a good idea to put an else in at the end of your if statements, do else. And then there's no condition here because we're just basically collecting all the other situations together. We're just going to print the number. Then I'm just going to get rid of these lines, these lines, these lines. And then we'll see we have our completed FizzBuzz challenge. So 1, 2 fizz, 4 buzz, then fizz for 6, 7, 8, and then 15 is our first iteration of FizzBuzz. Any questions on that? Because this is the kind of like most important. This is the thing that we want to take out of this hour is how to do this. Everything else is secondary. Any questions of what's going on here? Any errors? Any things that we don't understand conceptually? I really want to drill down on this and answer questions because this is kind of like the two biggest bits in programming is for loop and then in if statements. Why don't you do 3, then 5, then 15? Fantastic question. I love that question. Right, yes. So I've seen another error there. I'll get that to a minute. Why don't we do it a different way around? Well, let's try it out. If I move these around, so I'm just moving these around for now. We do this. Oh, let's scroll up, see if everything's okay. And what I'm going to look for is 15. Oh, 15 has labeled buzz. That's not correct. We wanted FizzBuzz. Why is that happening? Well, because when we go through our for loop again, when number equals 15, it goes, well, if the number is, when the number divided by 5 gives a remainder of 0, print buzz. Oh, yes, that's correct. I'll print buzz and then I'll move on to the next number kind of thing. That's not what we want to do. This is really, really instructive because, can I control Z? I can. Because we want to do it in order of like the most rare cases first. We want to be really specific with our first statements and then go down to the more general statements. Because if this kind of like triggers, if this is true, it won't even look at any of the other code. It won't even consider this. It'll just write this down and then continue with the next line. I see a lot of indentation errors. If you have indentation errors, I would recommend looking to see if you've got these colons. That's a very common problem, number 1. These colons are extremely important. And then if you've got the colons, I would recommend seeing if you've got these tabs. If you have 3 spaces, so if you have no spaces, it won't work. It'll give you an indentation error. If you have 2 tabs, 2 tabs will work. Okay, you just have to be careful with what you're doing. Okay, I'm not writing because if I do, after the webinar, you'll do the code. Yeah, fantastic. We don't really know of a good way to solve that problem at the moment. We'll try and figure that out, to be honest. Not sure if you're taking suggestions, but the fur ending here is creating an empty string in each loop and appending fizzle buzz in order. Yes. Okay, yes. This is what we're going to get onto later. And there's a lot of different ways to do this. That is actually a really good way of doing it. And I think later down the line, we try and generalize this code so it works for any kind of like conditions. So we introduce 7 for was, and then we have all these conditions being different as well. We do that later on, but that's like, I think, the last thing we do when we try and complexify everything. What variable is assigned to number? Okay, so this is a for loop question. So in a for loop, what happens is Python will run all of this code every time for a value in this list. And it'll assign the value for each time. It'll assign the value in this list to the kind of like, I call this a dummy variable, because it's a variable that kind of like we don't explicitly assign to a variable, but Python does it itself. So it'll run this code for number equals 1. So it'll go through this for number equals 1, and then it'll go back and it'll run it for number equals 2, because 2 is also in our list. Then it'll run all this, and it'll do the same code for 3, 4, 5, all the way up to 100. And only when it's done all of that will it then move on to anything that's in the next code box. So if I say print done, we'll get done at the bottom. It's only running this code when it's finished with this for loop. So I like to see it as Python goes da 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 da, and then da 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 da, and then da 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 da, and then again at the very end it goes. So this is when number equals 100. It goes da 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 da. Oh, I don't have any elements left in my list. Da da, and then finish the program. Okay, you're getting the sound effects for free here as well. That's a good deal. Okay, fantastic. I can't understand. Seems you're all speaking Python yet. Yeah, we're kind of going very fast here. I think part of that is because we all kind of like code every day. It's very difficult to kind of like slow down to that makes me sound like a massive horrible person, but it's kind of like yeah, it's kind of like hard because a lot of the time we're doing this like nothing, but obviously like you need to we need to kind of like slow it down so other people
Just for the record, Sam, you're not a horrible person. All right. Sam's the nicest person I've ever worked with.
Yeah. So I'm seeing a lot of things for flowcharts. Yeah. If you're finding this difficult, flowcharts brilliant. I love flowcharts. I've used flowcharts in loads of my code when it gets complicated. Don't be afraid to. I have a notebook here that I use, has a sticky label on it. I just scribble in that whenever I have code problems, and I just draw diagrams, and I kind of like say like, if this is equal to this, then what happens, and start to fiddle things around, kind of thing. Yeah, the indents dictate the end of the for loop. Yes, so indents in Python, and this is the double-edged sword with Python, is that indents are their own kind of syntax, in that they tell Python what code to run. In other coding languages like JavaScript, for example, your if statement would be like this. It would be like if v is equal to 1, and then you use curly brackets, and in the curly braces, then you write code kind of thing. And then when your curly brackets are done, that signifies the end of the if statement. But in Python, it's all done with white space, and that can cause some horrible errors. If it's number, then how do we know what our answer is after division, i.e. to know the statements are right or wrong? I'm not sure I completely understand the question. If it's number, then how do we know what our answer is after division? Lots of ways that you can do this. You could do this. So this is kind of like debugging. If you run this, it might give us an error. Maybe not. So this is going to print out for every time. That's not right. So what you can do is, if you want to know what this value is, if you want to know what the remainder is, then you can just print it out before you do the if statement, and then this will print out the actual. That's really complex to see, but it's this first number that is the remainder, I think. So this is the remainder when divided by 15 is 1, and then all the way up to Fizzbuzz we get 0, and then we know that when that's 0, we're where we want to be. So that's how you do that. You can kind of just like slow it down. My code literally has like 300 print statements in it, and then I go back and I clean it all up, and then I comment it when I'm done. Yeah, if you indent print done, it'll put done at the end of every list entry. Yes, that is correct. And I can just show that off now. And this is kind of like where, whoops, this is where white space becomes like a bit annoying, is that literally spaces can make or break your code. How do you know in the code at the end of the for and if statement? That's because we come out of the indent. So the best example is here after this if statement, we then come out. So we're back to, so there's like level 0 here of no indents, level 1 here of 1 indent, and level 2 here of 2 indents. We go level 1, level 2, and then we go back to level 1. That's coming out of the if statement. Yeah, levels is how I would see it as well. Yeah, and what you a good code practice, I'm not sure if we do this later on here, good code practice is to try and avoid having code out here. Like you want to then start to use like function definitions and things like that. Okay, where is the end of the if statement? The end of the if statement is here. This is the end because this is where our indent stops being at level 2 and goes back to being at level 1, if that makes sense. Yeah, the end of the for statement is here at this print done because we stop being at indent level 1, so level 1, and we are back to level 0 here. Okay, yeah, line number 22 here is the end of the if statement, or the for loop, sorry. So yeah, so well, that's more about writing good code than writing code which will run. Like it's just good practice not to have like massive long strings that are out to the side of your code, because at the end of the day, if I'm over here, I'm going to start to need to like scroll horizontally, and that's not useful. What you would do to avoid that is you would start to abstract this out using function definitions. This is something we're going to move on to now, I think. Yeah. Fantastic. Is there some way to check the code if the code is too long? So yeah, this kind of like goes down to like personal preference. In Colab, there's this vertical line, and the general rule is if you're over this vertical line, you're in trouble. So that's the general. I think there's something called PEP8, which is like a style guide. I think we're getting a bit off topic here, but I'll finish this. It's kind of like just a way of writing like code that other people can understand and just looks pretty and looks nice. So you'll have stuff like instead of writing code that looks like this is still valid, but it's just a little bit like cramped. So in general, we want to put spaces just to make it really easy to read. Okay, right, moving on. Let's get rid of this. Okay, right. So let me get up my notes. That's that, and this is this. And let me come down here. Right. Brilliant. Okay, so yeah, so one of the guiding principles of coding in general is that you don't want to repeat yourself often. You want to create code which is usable elsewhere. You want to basically make your code as compact as possible while still making it like understandable for people. So, and I think this is where and Joe, because Joe is in chat saying about string, adding strings together. This is where our paths are going to divide a little bit here. I actually really like Joe's solution to this this challenge, but there are multiple ways to kind of like solve this. This is my way. Joe's way seems to be a lot more with string manipulation, which I really like, but this is just the way that I did it at the time. So we're going to define a function called isDivisible. And I'll tell you what this is doing in a minute. It's like what we were doing earlier. And then I'm going to return num divisor is equal to 0. Okay, right. Panic. Oh my God, what have we done here? First thing, we are defining a function. So we are making our own functions. We have seen functions before. The print function is a function. The linspace function is a function. But we are defining our own now. And that's the great thing about Python as well, is that we can make our own functions. We can share functions with other people. We are telling Python this function has two inputs. We separate the inputs by commas. The first input we're going to call num, and the second input we're going to call divisor. And these, again, are dummy variables. These are just variables that we're using to tell Python what to do with the inputs. And then the output of this function is under the return keyword. So the return is what we're going to output. We're going to return num. So basically, this is going to be true or false. We're going to return, is the number, when divided by the divisor, is its remainder equal to 0, if that makes sense. So basically, this line is saying, is the number divisible by the divisor? Okay, right. So this if we put in, so if I then say print is divisible 15 and 5, that'll return true. If I do 15 and 6, that'll return false. Okay. Fantastic. And now we can actually change our code around. So I'm going to do something very similar to what is up here, but we're going to rewrite it using our new function. So for number in range 101, if is divisible, because this is just going to return true or false. If it's true, it'll do the code. If it's not, then it won't. So number 15, then print fizzbuzz. Whoop, buzz. elif is divisible. I'm just going to speed through this because it's very similar to what we've done before. Print buzz. elif is divisible, number and 3. Then print fizz. And else print the number. So what this is doing here is it's just going through each of our numbers, and then it's just checking the divisibility. If we run this, it'll then run exactly the same thing as before. So all we've done here is we've basically taken this logic up here, we've turned it into a function, and then we have used it in our for loop here. Okay, right. I'm going to move on again because we're going to just look at a very kind of complex, well, kind of like a more complicated way of doing this that is much more powerful. Okay, so we're going to do this function here. I don't know why I did this. Let me just copy and paste it in my notes. We're down here. Okay, so I'm going to define this function again for some reason. Should still be in memory. And then what we're going to use now is, instead of using just a, so how to tell the difference in speed of the two approaches in Python, this will be the same speed. If you wanted to test it, you'd have to use the time module and then time it. This will be the same speed. Why is it the same speed? Because we're basically doing the same thing, essentially. But we've just rewritten our code so it's more modular and it's more interesting. Okay, now I'm just going to show you this before we finish, because this is like an example of like the power of Python, really. Let me just get my notes up. What we're going to do is we're going to use a mapping. So this mapping, as example, is going to be a mapping of numbers. So we're going to take a list of lists. The first number is going to be our number, and the second number is going to be our output if it's divisible by the number. I'm getting a question. Return is the end of function. Yes, you always want to return at the end of your function. That's the terminal. That's the end of your function. That's the output. If you don't have a return, if you're using print instead, you'll get all kinds of errors. It's like a pipeline. Your data goes in to your pipe, something happens, and then the return is the output. Okay, right. So then we'll do our other things, buzz, and our last list, which is 3 fizz. Okay, so fizzbuzz example is this now. We are going to then write another function called generic fizzbuzz, number and mapping. And what this is going to do, so this is getting like a little bit complicated now. This list is basically telling us a list of divisors and our required outputs. So I'm going to do a for loop. So for divisor and outstring in mapping, and what this is going to do is this is just going to unpack. So we're expecting our mapping to be a list of lists. And each of those lists is going to have 2 elements in. The first element is going to be assigned to our divisor, and the second element is going to be assigned to our outstring. What I'll do for now is I'll print divisor and then the out string, and then I will just do a for loop down here for I in range 101, print generic fizzbuzz I fizzbuzz example. So when I run this, we'll get all of these numbers out. We'll run fizzbuzz. No, okay. What we're doing here, sorry, what we're doing is we're just taking each of our each of our 2 values, and we're just printing them out. I'm not sure why none is coming up here, but hey ho, we'll get over that. Okay, brill, fab. Okay, then fizzbuzz example, we're taking this number in, so we'll say if is divisible. We take our number and our divisor. So if the number is divisible by our divisor, then we return the out string. Okay, so what is this doing? This is like super abstract and super complicated. We are going to go through each of our pairs here, and we are going to check if our number is divisible by the first number. If it is, we print out the second entry, the second string. Okay, so why is this useful? Well, now I can start doing insane things, like I can put a 7 here and have was. And this will now check if a number is divisible by 7, kind of thing. We run this now. We'll see we have loads of things. We also have nuns here. I know why the nuns are coming out now, because we've got this other case. Yeah, sorry, we're getting to the end of the session, so I just want to get this in, and then I'll finish off. If nothing is returned from this function, we want to return the number. So we're going to turn it into a string using the str function, and this will give us what we had before, but now instead of 7, we have was's. Okay, so we're just getting to the end. I'll just quickly explain this in a bit more detail, because I think this is going to be the last thing we have time to do. So what we've done here, we've defined a function to basically condense our divisibility logic into a single function. We've then defined a mapping. So I've called this a mapping, which is just a list of lists. And what this is doing is we're taking the first element in each of these lists is what we want to test for the divisibility by. So we have 15 here. And then if the number is divisible by this first number, we then print out what is in the second element in this list. So if it's divisible by 15, we then just return fizzbuzz. If this isn't true, we then move on to the next element. So if it's not true, we then check for divisibility by 7, then by 5, then by 3. Then if none of these are true, so if none of these has triggered the divisibility bit, we then just return the string out. Okay, and then all we're doing as normal is we're then for looping through each of these i's, and we're just running this function. Okay, so quick few questions. Def statement has to define types. No, it doesn't. That is the great thing about Python, is that it is dynamically typed. Well, it's not always a good thing, but it's dynamically typed. We can call the mapping with anything. If I go, so if here I run generic fizzbuzz with a string, hello, and another string, hello, we'll just get an error. Why have we got an error? Because, whoops, because this doesn't make sense for my code. So what I've written has assumed that the mapping is a list of lists, and each of those inner lists has 2 elements. If we do any other list, any other situation, we'll just get an error. How would you fix this in practice? You would do it by basically doing if statements to say errors if it's not true. Okay, fab.
How much more you got, Sam?
I'm done.
You're done. Oh, yeah. Look at that, bang on time. I thought I was going to have to cut you up then.
So we can go there's like loads more stuff you can do here. For example, like what happens if I put this list or this in front of the 15 will get problems. But I recommend everyone just goes away and has a long think about why that might happen. But otherwise, we're done for now. That's all we have time for.
Wonderful. All right. Amazing. Thank you so much, Sam. Right. So we're going to close up there, folks. So remember, you can join the Slack anytime. We'll be sending the video out once it's finished processing on the Zoom servers. We'll get that to you via email. I've got a few honorable mentions. I'd like to thank Joe Allen, Advan, Jorge, Karen, Joseph J, and Batul. Batul, good luck for your exam tomorrow. Thank you to those just for pushing the chat a bit and helping out. That was really, really appreciated. I hope that's been really useful. Of course, thanks to the amazing, wonderful, fantastic Sam Ball for his, Sam's brain works at about twice the speed of me. So thanks for that, as always, Sam. We'll be back in March for our gender pay gap introduction to Python. We'll probably be running another introduction to Python as well. That'll probably be in April. So if you want to come back and refresh, it does change every time. We try and do different things each time. Although I think we've done FizzBuzz twice now. So we've done FizzBuzz.
We'll change it up next time.
Yeah, let's do something a bit more. Let's do Fibonacci or something crazy like that.
Oh yeah, that's a good one.
Yeah. So keep an eye on our Twitter. We'll be sending, if you've already registered, you'll be getting an email inviting you to our other events as well, unless you've unsubscribed, of course. But otherwise, just to say a huge thank you to everyone, wherever you've joined us from, wherever in the world you are. I know for some of you it's pretty late, so thanks for staying up to well past my bedtime. And yeah, thanks again. All right, I'm going to shut this thing down. Is that okay?
Yeah. Thanks for hosting and doing the first half of the session, Rob, as well.
That's all right. Yeah, my pleasure. My pleasure. It's always a joy. One day I really do hope to. Well, I don't think we will. I think this is actually massive compared to what we were doing. So to reach people all over the world is great.
Yeah.
But I have to admit, I really do miss three-dimensional people. That was the one thing I really loved about these sessions, is having everybody in a room, putting the tunes on and doing it. So maybe one day we'll have an international HiPy, and we'll contact some major government. We'll say this is important, give us some money, and we'll get everyone into. It'll be sunny, it'll be a beach or something like that, and we'll get everyone in a room. Yeah, after COVID, of course. Okay, right. Okay, cheerio, everybody. Thanks again, Sam. Have a lovely afternoon, and see you next time. Take care. All the best.
Yeah, brilliant. Okay, bye.